Hi everyone, I'm Hannah Hansons-Reed, the Education Specialist with the Oracle Applications and Technology Users Group. Welcome all to today's e-learning session, Migrating Legacy Architecture Apps to Cloud Services, Public and Private. Before we get started, I just want to quickly introduce everyone to OA2UG in case you're new to our programming. OA2UG is a community of Oracle users, and we provide education, support, and professional development to our network of members. We do have a few fun events coming up, including our Professional Development Virtual Education Week, which is happening the first week of October, the 5th through the 9th. So if you're interested in learning more or have any questions about OA2UG, please feel free to use the chat box in your control panel, or you can visit our website, oa2g.org. And lastly, I just have a couple of quick reminders about today's webinar. Everyone will be on mute throughout the session. However, you're welcome to send questions at any time through that question box in your control panel. We'll have time at the end for a Q&A. We are recording this session, and the recording will be accessible to OA2UG members in the knowledge base. I'm going to go ahead and send the link now in that chat area where the recording and the slides will be posted after this event. Now I'd like to turn it over to Sandy Levitt and Marlin McNeil, our presenters for today. Thank you both for being with us. The stage is yours.
Hi, good morning and good afternoon for those of you that are in later time zones. And I'm going to do a quick introduction here about myself. And there we go. Oh, I went too far. I'm sorry. My name's Sandy Levitt, and I am with Stromasys. And before I joined Stromasys, with whom I've been with for about 6 years, I spent 27 years at what was DEC, Compact HP, and I worked mostly supporting the Unix operating systems, such as Ultrix and True64. I was also a pre-sales engineer. When I joined Stromasys, I joined as a pre-sales engineer, a general pre-sales engineer, senior engineer, and now exclusively part of channels and alliances. And I've also been very involved, as everybody's been moved to the cloud, as being the Stromasys Cloud Product Manager. So I'm working with all the alliance, once again, because we are very tightly aligned with all the cloud vendors, working very closely with all of them. And I'm going to turn it over to Marlin to introduce himself.
Hello, everybody. Glad you could make it to the webinar today. Good to be with you here. I'm Marlin McNeil, the managing partner and co-founder of the Yucca Group based in Albuquerque, New Mexico. Early on in my career, I worked at Sandia National Laboratories, which was just the absolute dream job for a young computer scientist right out of undergraduate school, and attended graduate school at the University of New Mexico while I was working at the labs, and that was a fun experience. That basically gave me exposure to just about every kind of legacy architecture that existed, I think, at that point, minus possibly a PDP, but Sandia had some of everything pretty much. And after I worked at Sandia, I hopped to the private sector where we had the opportunity to virtualize Oracle real application clusters on VMware. In fact, that was the very first Oracle database that I ever virtualized. So we went, right for the throat, right out of the gate. And developed some expertise in that area, helped pioneer that a lot. And I was technical editor on the VMware Pressbook virtualizing Oracle databases on vSphere. Have since been working with Stromasys on migrating legacy workloads, including the databases that go with them, onto the emulators, the legacy architecture emulators in modern cloud architecture. So it's been really fun seeing some of these ancient one-off utilities taking advantage of all the goodness in the cloud.
So moving on here, I'm going to turn off my webcam now. I just wanted everybody to see who I was, so you had an idea who your speakers were, but I'm going to stop sharing the webcam. So to move on. Anyway, so moving on here. I apologize. Okay, so the agenda we're going to talk about today is the unfortunate truth about legacy workloads. And, what are these options for these legacy workloads? Why lift and shift, legacy workloads, putting them in the cloud? And just in general, the legacy architecture on x86 Linux. And then we're going to go into how to migrate these stuck legacy workloads, including talking a little bit about performance and what a typical migration might look like. So the truth about legacy workloads, first of all, what kind of legacy are we talking about? We're talking about a lot of this legacy that came out in the 1990s, early 2000s. We're talking about, a lot of the old digital legacy stuff, HP, Suns, and we're not really talking about IBM in this case, but as far as this webinar goes, because IBM is a whole different beast, and with IBM, the whole migration situation is something that you would do on your own. But basically what we're talking about here is that you have these applications that were written way back when, and they're very stable, and they do their job, and they do their job well. And they were written on top of these old legacy operating systems that were back, like I said, from like 80s or 90s. A lot of them were, even though they said Unix is Unix, it really wasn't. Like HPUX was not the same as Solaris, which was not the same as True 64. There, it was not, even though it was Unix is Unix. So now the operating systems, are more like just Linux and Windows, but back then it was a lot proprietary. We had VMS, we have NPE, and then you were running on all this hardware. So this hardware, which is now 30 years old, it's not a question of if this old hardware is going to fail, but when. But meanwhile, you have the software and these applications, and there's a reason why they're still running, and they're a lot of times very imperative for the business. So, are you really blindsiding yourself? The issues that you're dealing with here is, you're dealing with the instability of the hardware and the diminishing the skill set. There's no longer these field engineers that really know this old hardware that can come out and fix these boxes and do the things that need to do. And where are you getting these spare parts? And what is it costing you to maintain these legacy systems? And it's not just the cost of the actual boxes, but the space they're taking up in your data center, the power, the cooling. But the biggest issue is what happens if they go down? What is that downtime risk? And, what is, how are you not, staying up at night worrying about failure? So we're talking about something like this. When you look at some studies that have been done, hardware failure accounts for 31% of unplanned downtime. So usually for at least 1/3 of systems that go down, that's unplanned. And when you look at the Fortune 500 companies, 60% of them have at least 1.6 hours of downtime per week. So that's a lot of downtime that can cost sometimes thousands, if not millions of dollars, depending on how long this downtime is, all reliant sometimes on this legacy hardware running these applications. So when you're talking about the workload stuck on these old architectures, we're talking about applications that are out of support, such as and there's regulated industries. It's very hard to sometimes rewrite an app or redo an app because it took a lot of rubber stamping, saying this app works. I remember when I worked over at Digital and customers were running on older versions of the operating systems, and we tell them, hey, you need to upgrade from this old version to the newest version. They say, we can't. We have proven our app works on this version. It's going to take a lot of work to unrubber stamp it. Things in the financial industries. There's a lot of customized apps that were compiled on Solaris and VMS. And the people who wrote these apps, a lot of these authors have since retired or no longer available. There's, to rewrite this code is going to be very, a lot of time, very expensive. And sometimes there's reasons. You have to keep old information for 7 years. So, and then finally, sometimes they're stuck because companies are buying companies. And one of the things that they're doing is they're acquiring what the other company had in their IT. So they are acquiring some of this legacy hardware, and they're still trying to figure out what it does, what are the applications, and how important are they. So these are some of the workloads that are stuck on the old architecture. So, you know, why should you lift and shift and go with emulation? I mean, you can leave things the way they are. And that's, as I've proven, downtime can be very expensive and can be very risky. You can go on eBay and buy spare parts or wherever you can find spare parts. And that's getting harder and harder to do, because we're hearing a lot from customers who keep telling us we're down to our last bit of spare parts. So that once again becomes risky. Of course, you can migrate and you can rewrite the code, and a lot of people are doing this, and that's some of the work that does get done. And when you lift and shift to the cloud is done by migration, and that's part of the strategy, and that's part of what we're discussing here, is that you can do that. But at the same time, there's worthwhile times when it makes sense to just lift and shift this old legacy workload with emulation to on-prem or to private or public cloud. And in the case, or while you're doing the migration, why not start that first step and do the lift and shift? So I'm going to let Marlin talk a little bit about legacy workloads in x86 architecture in the cloud. Go ahead, Marlin.
Okay. Yeah, so what we're kind of talking about here, the workloads that we're addressing today that need to, for whatever reason, kind of need to stay on legacy architecture at least for a moment, are the ones we're talking about. And these are the ones that have, in lots of instances, installed migration projects, right? Where everything, for example, a friend of mine here in town who's a local CIO of a financial institution was able to migrate 92 or 3 applications. There were 3 of them that wouldn't migrate, and directly to Linux in VMware. And those 3 that wouldn't migrate those are the types of applications that we're addressing here. And a lot of times those are the ones that would have to be refactored, or those kinds of things, or where you maybe have to be refactored from the ground up. For example, someone wrote the application 25 years ago and then subsequently retired, and nobody even knows where he lives anymore. Those kinds of things, or that would cost an inordinate amount of time or money to be able to refactor and move over, or something where you have no support on your existing hardware. That's the target application that we're addressing here. So with that in mind, we'll move forward in kind of that context.
So why do customers choose to move to the cloud these days? What is the compelling argument about going from traditional infrastructure to the cloud? And a lot of this is it does relate back to the cost. And for one thing, when you move to the cloud, you're dealing with operational expense versus a capital expenditure. And and there's a lot of flexibility in that. There's a lot of, how do you guess on capacity? How do you guess how many machines you need? You may only need, like, for example, a lot of retailers need a lot more capacity around, let's say, December and Christmas time, and they need less capacity in January. So you don't need to worry about like guessing what you need and how you're going to meet your capacity. You can just in cloud easily spin up new machines, which increases your speed, agility. You're not maintaining these data centers, and maintaining data centers, in terms of the real estate, the heating, the cooling, the actual boxes in the data centers. You're no longer in charge of trying to figure out, for example, on some of this hardware failure, how you're going to fix this hardware. And, and other issues that you have to deal with when you're dealing with buying traditional infrastructure versus, the cloud, which, like I said, also in the cloud, if you're a global company, you can go global in absolute minutes. So there's a lot of advantages to going to the cloud, and a lot of customers are seeing this, and they're sort of being told, move everything to the cloud. And then, of course, you do have, like I said, the applications that are stuck. sitting on some of these legacy workloads.
So
So once again, Marlin.
all right, thanks, Sandy. So yeah, there's a lot of the advantages to being able to migrate these legacy workloads that otherwise, were kind of stuck where they were, as it were, that have stymied all of us from time to time in terms of, okay, great, what do we do with this now? We have to get it off of here. Our data center is closing. We need to move it to the cloud, but we can't find a way to gracefully or in a timely fashion refactor or whatever. So by having the option to migrate, what that amounts to is that we can migrate these without any refactoring. We can get them on supported hardware so that everything all the way up through the Linux layer that's hosting the emulator is supported by large scale organizations like Google, Oracle, AWS, Microsoft, and in the case of Azure, things like that, or a larger scale, hybrid or private cloud infrastructure like VMware Cloud on AWS or those types of things, right? And certainly that reduces the support cost because you got your mainstream engineers now are able to support these applications all the way up to the application level. Or just below the application level. And of course, you get dramatically improved availability because then you have all the availability features of the cloud where you can do, go into HA clusters, you can replicate between availability zones, you can do snapshots, you can do cloud backup with your cloud backup utilities or with Veeam or things of that nature. You can replicate with stuff like Zerto, that kind of thing, replicate to far off-site locations. You can certainly improve security dramatically because then all of a sudden things like zero trust architecture become available to you. So you can do microsegmentation if you've got on-site or a hybrid cloud. You can use all the goodness of NSX and those types of things, access control lists, and that sort of thing that really enhance the security of your that's existing in your legacy application. And then certainly you have the opportunity to utilize some of the nice new automation tools. Just an example is you can use something like vRealize automation in VMware to clone a template of your legacy application for dev and test purposes, that kind of thing, so that your folks who need to work with things aren't impacting your production workload, or you can clone it for doing reporting purposes so you don't have a performance impact on production, those types of things. All right, so
yeah, so I'm going to talk about what legacy architecture emulators we're talking about here. And we're basically talking about things such as SPARC, VAX, the PDPs, which go way back, AXPs, which are the alphas, and PA-RISC, which are the PA-RISC, such as HP 3000, 9000. What we're not talking about here, and like I mentioned earlier, is we're not talking about the IBM AS400s or RX6000s, because like I said, there's no real emulator per se for IBM. A lot of the movement of IBM and old COBOL programs are much more complex and not something that we can offer in an emulator at this point. And besides that, we would gladly create an emulator, but that would, we're waiting for IBM to let it, to work with us on that. So basically, we're just going to focus on what we can do and we can be moving to the cloud right now. So when we're talking about the portfolio of what legacy emulators are out there, of course we have CARE and VAX, and this is probably one of our oldest, longest product that we've had. We've sold many licenses. We know what we're doing here, and they're out there everywhere. They were out there in the government, process control. They were all over data centers. The VAX running VMS operating system were very, very popular and did a lot of, from coming from the old Digital Equipment Corporation, and they're still out there, and they're still running these great applications out there that are vastly needed. And we still see a lot of customers coming to us with VAXs that need that are these things are 30 years old, and they want to emulate them, and now you can emulate them actually and include these large boxes into the cloud. So then you're talking about Karen XP, which covers the alpha boxes that DEC Compact did, and running the alpha chip, and this was running either also VMS or running the True 64 operating system. And we've also done many of these systems running out with the alpha systems and put them out there. And as a matter of fact, one of our first case studies going into the cloud were the alpha systems. So we're out there and we have them sitting in all the major cloud providers. We have an alpha sitting in Oracle, we have an alpha sitting in AWS, we have one sitting in Microsoft. So that's generally where the first people, when we first started moving to the cloud, these were the people that were coming to us, was our alpha customers who were saying, hey, can we move this now to the cloud? So now we're talking about Karen PAR, and we started off with what we would call HPC 1000 MPE operating system emulator, and it's the PA, these are the HP PA-RISC systems, and the 3000s did a lot for inventory processing. And then we decided to add a new product that just came out called Karen PAR 9, which is for the older HP UX systems, such as HP UX 11.11, 11.23, and it's just the PA-RISC HP 9000 that we're dealing with here. We're not dealing with any Itanium boxes, but currently we do have something for the older HP UX, and like I said, the MPE operating systems with Karen PAR. And of course, we have Karen SSP, and a lot of the focus here on this webinar and a lot of what Marlin talks to has to do with our Karen SSP, which is the SPARC emulator. And we developed it for the SPARC architecture, and we go everywhere from the small old workstations all the way up to currently we can do some of the work with the Sun 4V architectures, and especially the sort of older ones like the T1s and the T2s. When you start moving up to the newer ones like the T3, T4, T5s, the performance of the SPARC chip is pretty fast, and as Marlin will talk about later, there is some overhead to emulation, which makes it so that if these are in full production, it may not be the right candidate, but in a lot of times we have to look at that from a performance standpoint. But we do range the whole family of Sun systems as far as what we offer in the emulators that can move your legacy platforms to the cloud. And of course, we still have Karen PDP, and there are some PDPs still sitting out there, and we do still sell licenses for that. So now I'm going to move it back to Marlin, who's going to talk about the migration of stuck legacy workloads and move forward.
All right, thanks, Sandy. So to start off with, we know that a lot of the workloads do migrate, and certainly the idea here is to migrate as many of those to native Linux or Windows in the cloud service of choice as possible, right? So we certainly get the optimal support, optimal performance, everything along those lines. And basically those are applications that have a vendor supported procedure for migration to Linux, Windows, whatever, a modern OS in the cloud. And so a couple of examples of those would be Oracle databases, where you can do standard Indian migration from Big Indian on some of your legacy architectures to Little Indian on Linux, for example, or Windows. They're both Little Indian formats. You can migrate Oracle eBusiness Suite directly across the Oracle's published good procedures for doing that. Oracle Forms, Java applications. Of course, I think that was the point of Java in the first place, was to make it so that those applications are portable to pretty much anything everywhere. And tons of other commercial off-the-shelf applications are able to be migrated directly to Linux or Windows in your native cloud architecture. So anything that you can migrate there, do that first. That's the first option and first thing to take care of. Then the second thing is, so where can we migrate the ones that aren't the applications that can't be nicely migrated with a vendor supported path? And the short answer to this is anywhere that will support the Red Hat kernel of Linux. And so there's a big old list of stuff, Oracle Cloud, Google Cloud, AWS, Azure, IBM Cloud, etc. I'm sure I'm leaving somebody out. You can do it on local virtualization infrastructure. So for example, VMware ESXi or Hyper-V, or basically anything else where CentOS Red Hat kernel will run. This also works great on any of the VMware hybrid cloud solutions like VMware Cloud on AWS or the VMware solutions on Oracle Cloud or Azure. And there's also an option to move these directly onto native hardware. So you install Linux, then the emulator, and then you can take advantage of the hardware-based virtualization that will give you about 30% more performance above what you could get in a VM, for example. So if you have high performance demands, a highly demanding workload profile in your legacy system, that's certainly an option. And even those can go to the cloud. There are people like AWS who will give you a bare metal server that they will manage, and you can do that as well. So the options are pretty much endless in terms of where this can go. So anything public cloud, hybrid cloud, on-prem cloud, it all works. So first of all, the thing of paramount importance is to make sure before we start migrating that we know exactly what the workload profile on the legacy architecture looks like, so that nothing bites us down the road. And that's extraordinarily important given the nature of what it takes to make an accurate emulation of the legacy workloads. So first things we got to, some of the things we have to worry about certainly are the operating system release of your legacy architecture, your storage configuration, how that's set up in terms of numbers of disks, on how many SCSI channels or fiber channel adapters, those types of things. How your file system is configured and organized. If you've got any guest OS virtualization going on. So for example, if you have Solaris zones running in your legacy architecture, that's a special one-off case that has to be addressed very specifically. And if you have things like any type of proprietary peripherals, serial capture cards, any other kind of data acquisition hardware, those types of things all need to be rolled in so that we make sure that when we get to the target system on x86 architecture in the cloud, that we have addressed everything that needs to be addressed to make sure that you have a successful migration. All right. So basically, what can be migrated? That's kind of the question of the day. And this is pretty nice the way a lot of the legacy operating systems are architected. It's fairly easy to find a configuration that can be migrated. So you can do everything from migrating the entire OS, lock, stock, and barrel, including the IP address and everything. You can just move it over in its entirety. You can pick up, file systems from like mount points of your physical disk space, things of that nature. Even directory structures that are taken out of the legacy OS. For example, migrating opt or var, those kinds of things. And if you're doing the Oracle default installation, for Oracle database, you would include things like U01, for example, if you're familiar with Oracle, and you can just pick those pieces of the file system to migrate those one off to a fresh install of the operating system if that's what your architecture requires. So for an example of this in Solaris, you can migrate UFS root file systems, including all the boot sector and everything else, ZFS file systems, root file systems as well, UFS regular file systems and ZFS regular file systems, and even VXFS file systems. And the same thing holds true with VAX, with Digital Ultrix, with any of the other legacy systems. They all have similar type capabilities that will let you migrate just what you need to migrate. So some of the methods, of course, standard old backup and restore, as if you're restoring to doing a bare metal restore. That always is an option, and sometimes that's a really good option because then you're getting bit for bit exactly what you had on your legacy system, and there's an awful lot to be said, even though there's a little extra overhead to that. Sometimes that's a really good way to go if you've got a complicated installation. You can migrate file systems a piece at a time. You can recover from an old archive if you need to do a point-in-time recovery, those types of things. So examples in Solaris again, you can use UFS dump to move parts of your file system. You can do a ZFS file system migration. ZFS is one of the really nice inventions of recent times. ZFS is a wonderful thing. We'll talk a little bit more about ZFS here in a little bit. You can do a flash archive, and flash archives are really a very elegant way to migrate an entire system so that there's no noise in terms of having to manually reconfigure things and introducing the possibility of human error in those types of situations. So a FLAR can reduce and eliminate basically almost all of that. So there's a lot of nice ways to migrate things, and these have to be determined when you evaluate your workload. You figure out which is the optimal way to migrate your particular workload. So there is no silver bullet here. The answer is that it depends. So you have to be very careful up front in evaluating what you've got to find the optimal way to move things. To talk about making sure that we've got ample capacity on our target system in the cloud. Again, I can't emphasize enough making sure that up front that we understand the workload profile on the legacy system so that we can make sure we have enough resources provisioned on the target system to make sure that you don't have a performance hit. And one of the primary reasons that this is so important is because in order to translate from x86 CISC instruction set up to whatever your legacy instruction set is, whether it's SPARC or VAX or whatever it may happen to be, it requires, as a rule of thumb, about 60% CPU overhead. So for example, if you're running on a 1.2 gigahertz SPARC CPU on your legacy platform, that would require a 3 gigahertz Intel processor in your target architecture in your cloud service to render the same type of performance, the same CPU performance as you were getting in your legacy architecture implementation. And so that can vary a little bit by workload. But 60% is a good rule of thumb starting point. Then as you get things, do your test migrations and things, you can run some tests and make sure that you know exactly what your requirements are, and that can go up and down a little bit. There are a couple of ways to gather this type of information. Again, we're using a SPARC example here. Stromasys provides a script called sysinfo that gathers all kinds of information about configuration and about workload profile of your legacy system in C2. We ran across a situation a little while back that was very interesting because the legacy system was running on it was 2.8 gigahertz SPARC CPUs. And so we had these wonderful discussions about that they don't make an Intel processor fast enough to deliver the same kind of performance that a 2.8 gigahertz SPARC CPU would deliver. But then we stopped and looked at things and realized that there were lots of threads in this application, but none of them seemed to be running all that much. So we pulled out the Solaris utility MPstat, which gave us the peak utilization of each of those threads, and we discovered in the process that the highest utilization thread peaked at 20% of that 2.8 gigahertz CPU, and most of the time was riding below 10%. And so what that allowed us to do is then we actually were able to migrate that workload over to the Intel architecture running on about a little less than 3 gigahertz, I believe it was 2.6 gigahertz, because the actual workload profile was such that it didn't require all of the legacy CPU, so we were able to move it effectively onto an Intel an Intel infrastructure that actually has been in manufacturing for a while. So one of these days when they come up with 7 gigahertz Intel processors, that'll be great. That'll solve a whole bunch of problems. For the time being, we had to be creative about gathering the statistics, so we really understood the workload profile in depth, and then that made it possible for us to get where we needed to go. All right, so now in order to make sure that we get the type of performance we need out of our target architecture, it's imperative to follow best practices at every single layer of your tech stack. So if you're dealing with something that's hybrid or on-prem, you want to make sure that everything at the physical layer, the hypervisor layer, and the VM layer that you can control are tuned as much as possible for a large workload. And we'll talk a little bit about a couple tips and tricks on that here in a moment if you're running anything that's on-prem. If you're going to a public cloud, then that will allow you to, you just got to make sure that you pick the right cloud shape to match your workload profile. And that you have the right network connectivity and storage and those types of things. So your configuration in the cloud needs to match what your workload profile is. Then of course you have to tune everything at your Linux guest OS running inside that VM on the Karen emulator, and certainly inside the legacy OS itself. So for example, how you would configure your disk configuration inside of Solaris, for example, or VMS or something, to make sure that you have enough queue depth, those kinds of things. So the things that you really want to make sure that you have in terms of where you're gonna to make sure that you're going to land where you want to land on your physical workload is, first of all, you want to make sure you get the fastest CPUs possible. And it's always a good idea, even if your current workload doesn't require the fastest possible. You know how it goes, right? We all know that anytime things go faster, everybody wants, will suck up that additional bandwidth and as quickly as possible. It's kind of like the gas laws, right? The computing demand will fill to accommodate the computing space, and so make sure you have fast CPUs. Certainly, one thing that we discovered is you need to get the fastest storage you can. So if you have access to NVMe or SSD storage, by all means do. All flash storage makes a huge difference and can mitigate lots of other performance issues in these types of cases. In order to make sure that you have all of your overhead requirements met, it's necessary to add 4 additional CPUs to your legacy workload. So for example, if you're using Solaris again as a an example, if your Solaris workload requires 8 CPUs, then your Linux guest host OS that has the emulator in it would require 12. So you'd need 4 CPUs for overhead, for I/O and process scheduling and all those kinds of things. And then the additional 8 can go directly to running your Solaris workload. You also need an extra 12 to 16 gig of RAM to support Linux and all the other overhead. So for example, if your Solaris workload required 12 gig of RAM, then your Linux guest OS would require at least 24 gig of RAM to be able to meet all the overhead requirements in a performance optimal configuration. The next thing that we really stress is making sure that the disks in your target architecture are distributed as much as possible. And we'll talk about this in a little bit, but what that means is make sure that you have as many disks as you can on as many SCSI buses as you can. All right, so that you have the greatest number of queues with the greatest aggregate queue depth possible, so that you can run more transactions concurrently, basically. And so, for example, the ZFS pool on Solaris addresses this just perfectly, where you can put a whole bunch of disks and then present it as one file system, and so you get all the goodness of lots and lots of distributed disk I/O underneath, but your application doesn't really know the difference. And so, except for that it goes really fast. So if you're using any type of hybrid or on-prem architecture, some of the things that you want to do would be the same best practices as tuning a enterprise Oracle database on VMware or on Hyper-V or any of the others. These apply to all of your standard hypervisor environments. So first thing you want to do is you want to keep this within the NUMA node boundaries. If you have to cross NUMA node boundaries, you're going to take probably a 30 to 35% performance hit. So you want to keep your number of CPUs and your number of your amount of RAM within one NUMA node. And basically, a NUMA node, just for review, is all of the CPUs and memory that's associated with one socket on your motherboard. So if you have 2 sockets with 6 cores apiece, then one NUMA node would be 6 cores, and all the memory that's in the bank of memory that's attached to that one socket. So you want to keep your CPU ready under 300 milliseconds in a 20-second polling cycle, and you want to make sure that your storage block alignment does not that your storage blocks stay aligned. So for example, in VMware, for an example here, if you allocate your storage and provision your storage through vCenter Server, it will automatically make sure that your blocks are aligned, because if your blocks are out of alignment, then pretty much nothing will run fast, and you won't get performance that you need under any circumstance. Even on native apps, your performance will be really terrible. So those are the types of things that we need to pay attention to there. Profile of a typical migration, just kind of in a nutshell. Again, make sure that we gather the workload requirements of the existing workload profile. Make sure that we have all the configuration details under control. Then we would do, for a database, for example, we do an Indian migration of your Oracle database or whatever other database that you might be running over to native Linux if possible. If not, then you can migrate that into an emulated legacy environment, and we've actually had fairly good success doing that as well. So you have to understand that you're not going to get terrible lots of disk space, but if it's enough, then if you have things that won't migrate nicely, like proprietary external procedure calls and things of that nature, then you can certainly run. You can get a good enough performance to run a database in Karen under a moderate workload. So, but migrate everything you can to native Linux, and then tune that all up to get your optimal performance there. Then go ahead and configure your Karen emulator to deliver the type of performance you need to match your legacy workload profile. Then migrate your legacy application using any one of the appropriate migration methods, and get your Karen emulator tuned for performance. So number of disks distributed across SCSI channels and things of that nature, and then all the performance tuning that you would do in your legacy guest OS like Solaris or VMS or whatever. And then migrate your web servers to wherever that needs to go, if that needs to go to a Karen emulator and in its legacy configuration, if you can migrate those to something like Tomcat on Linux in a VM or something along those lines. And then that's the basic algorithm for migrating your applications over. And at that rate, you can run it up and it'll run just like it did in your legacy architecture. So now, this is a disk performance test that we did in a laboratory. And so these are actual numbers that we got. We were using some Dell T420s, and we had a 16 gigabit fiber channel attaching an Excel Store P710 all flash array, which is rated at 700,000 IOPS sustained. So we had a lot of IO throughput in the back end. We set up Solaris 10, release 11, and set that up and used Oracle Orion, which is the Oracle IO numbers. That's one of their disk throughput utilities that will give you a feel for how fast a workload will run on a target system. We ran that and gave our VM 6 vCPUs, 56 gig of RAM, so that again, our VM with everything would fit inside one NUMA node on that T420, and then turned it loose with a simple test in Orion, and we were able to generate, and we did this a couple times, and got 533 megabytes per second of sustained throughput out to the disks, and we were able to get just shy of 4,000 IOPS sustained. And so then the way that we did that, because when we started off, we just did one big file on one SCSI channel, and we got about half of that. And so then we distributed the disk IO, put 4 disks on one SCSI channel, 4 disks on the second SCSI channel. So the Karen SPARC emulator provides two SCSI HBAs, and distributed, got 8 disks distributed across 2 channels, and that basically doubled our IO to what you see here. So it's not terrible bad. You're going to get vastly better performance out of that, out of native Linux, but for an emulated legacy architecture, this is decently performant. It's not terrible bad. It's enough to support a lot of the and match the performance you get from a lot of your legacy platforms. So with that, kind of there are risks of leaving legacy architecture in production, and we're all painfully aware of that. Probably wouldn't be here if we weren't. Of course, that drags down resources and everything else from your IT department. We can lift and shift using legacy architecture, and of course, everybody knows about the benefits of cloud migration, which are legion. There's a ton of good things about going to the cloud. And the top technical takeaways, again, are make sure that you completely understand your workload before you undertake a migration. Second, make sure that you get enough resources provisioned on your target emulated environment to support that legacy workload profile. Third, optimize at every single layer of the technology stack that you have access to, and make sure if you don't have access to it, like for example in a public cloud, you pick the right shape that will meet your needs. And then you can migrate existing application configurations. You don't have to reinstall them or anything else. You can install them as is without any reconfiguration or anything. And in a lot of cases, you don't require reinstallation of anything, with the possible exception of the operating system. And if you're using something like a flash archive, for example, you don't even need to reinstall that. You can migrate the whole entire thing over and drop it on your new disk, and off you go. So with that, we appreciate you coming today, and we've got a couple minutes for questions and answers.
Wonderful. Thank you both for that great presentation. Really appreciate you joining us and sharing your knowledge with the OE2UG community. Just a reminder to everyone, if you do have questions for either of our presenters, you're welcome to send them in the question box in your control panel. We do have a few questions as well as a comment. I'm going to just share the comment first in case this is news to anyone. VMS on bare metal X86 is coming. So if anyone is interested in learning more, I do have a link that one of our attendees shared. And now there's a few questions, so I'll go ahead and read them and then share them in the chat for everyone to read along. The first question is, are there any changes to the applications once they're migrated to the cloud?
Marlin, do you want to take that or you want me to take that?
Certainly, yeah, absolutely. And that's kind of back to the very last point that I made in the summary. That's one of the great things about being able to migrate to legacy or to an emulator is that you can pick up your application exactly as you know the author compiled it 25 or 30 years ago, and move that bit for bit into the cloud, so that no, it is exactly the same down to the bit level. And so that really it gives you a lot of confidence in being able to move these legacy applications because they work exactly the same. You don't even have to recompile the executable or anything. They work exactly like they did on the legacy platform.
Great, thank you for answering that. The next question is, what are challenges you experience while migrating applications from Compact True 64 Unix or IBMX AIX to Linux x86 in cloud? And I'll go ahead and send that since it's a little bit of a technical question.
Yeah, my background is more on the True 64 side. First of all, at this point, we don't really address the IBM AIX side because that is very complex, and that's something that a lot of the cloud vendors, whoever the cloud vendor is, have whole teams that are dedicated to how you're going to get your IBM systems over. We'd love to have an emulator, we just don't. As far as True 64, there shouldn't be really any issues going to cloud. The only time that you would run into, just like with any of the other operating systems, the only thing you have to be very cautious about is if you had any kind of extra peripherals or anything like that. And as a matter of fact, True 64, the other area would be layer 2 networking, and there isn't so much going on in there. Maybe, if you had to deal with like X25 protocols and how that might fit in, but we actually have migrated True 64 to the cloud, and there was not any kind of problem doing so. So getting that out there, coming off an alpha, should not be any kind of issue.
Great. The next question is, how long does a migration take?
And I can continue with that, but typical migration, there's a lot of prep work, as Marlin went over. There should be a lot of prep work, but the actual migration usually can take less than a week. And Marlin, if you have anything more that you want to expound on that, that would be great.
I would say, yeah, the important thing to keep in mind here is making sure, and the vast majority of the time actually is in the preparation. The preparation of gathering information on your workload profile and of making sure that your target environment is provisioned and sufficiently, takes the vast majority of the time, to the point where the actual migration per se is almost academic, and in most cases is driven by the speed of your IO, of your network and your disks. And so most of the time that takes very, very little time relative to the entire process, that allows you to guarantee that you get a good end result.
Great, thank you. We have a few more questions. So the next one is, will this work on HP UX 11- let me send this so you can read along, 11-11/11.23 applications already running on HP UX containers?
We would need to look further into that because I'm not sure about that, and I would have to let our HP product manager look at the HP product manager look at that. If you want to reach out and send an email afterwards to me, my email is on the screen. We can forward that. I do know that we do support only, like I said, the PA-RISC, and we support 11.23. I'm not sure about the what you mean by HPUX containers, because that's not really my area of expertise, but we can forward that on and see what we can do for you.
Great, thank you. And I'm going to just add to that I think this next question may be another one that may be worth following up. So again, if for all of the attendees, feel free to jot down Sandy and Marlin's emails if you want to reach out for more specific questions, as well as these slides will be, again, in the knowledge base on OETG's website, so you can save their emails and the slides there. This next question may be one of those that might be better, but I'll go ahead and ask. It's a two-part question. Is there a slide for price comparison or estimates and ongoing support cost? And is there any model or company using it in cloud for SPARC and HP?
There's not really a slide for price comparison and support cost. We do have a calculator on the Stromasys website where you can look at, plug in your numbers and everything and see what comes out. So you may want to come to our website and explore that, because we did try to create a calculator, but you would have to put that in there. And as far as there are companies that are using, of course, for SPARC, and because HP is our newest product, there are some projects that are in progress right now that are that I can't really talk about, like individual companies, because we do sign NDAs and stuff, but there are things in the works and or already existing. And so, like I said, if you reach out to us, we can talk to you individually. But I can't really say too much out here because of those NDAs.
That makes sense. And again, I'm happy to, I will send after this next question the link to the Stromasys website where you can find that calculator. The next question is, are the emulators installed on the client or server side?
The emulators are installed on the server, like the Linux. They're installed on top of Linux server. I don't know if Marlin, you can even expound a little bit more on that, because the client will actually be it's the host versus client or guest operating system. So Marlin, if you want to explain that a little bit more, that would be, you can as well.
Yeah, you bet. So basically, your legacy workload is running on a server, on whatever kind of a legacy piece of physical hardware server. And what the emulator does is it basically makes a software version of that server that then that's portable around to various cloud services and whatever. So yeah, I would say in that context, it definitely is running on what we would call the server side. So it's basically a server that is just implemented in software. And so your clients, your application clients, would you don't even have to change them if you can add the same connectivity to the server. So for example, if you can assign the same IP address to your new virtual server, then your client applications don't have to change a thing. They connect via the same network connectivity mechanisms, ostensibly using the same IP address if you can arrange that with your network guys on the back end. And so yeah, I would definitely be inclined to call it the server at this point, where you don't really have to touch the clients. And that's one of the real beauties of this, actually, is that it requires no reconfiguration of any of your existing client infrastructure.
Great. We have one more question, and I know we're just at time, so I'll just ask this last one. And if there's additional questions, and again, if you want to follow up, please feel free to reach out to Sandy or Marlin, or to send me a message through the chat, and I can take down your information so we can follow up. The last question is, who provides support if we experience any issues or bugs at the OS level after migrating to the cloud?
That's in debt. Well, usually it's whoever's providing your normal, we'll look at that. In other words, when you'll have support from Stromasys or from a partner such as Marlin, who is one of our partners, who also understands our emulator very well. And so whoever's providing your first level support, and we'll be able to go through if you run into a problem, and we'll look at that, and we'll be able to, we do have that OS expertise in-house at Stromasys, and like I said, with our partners have that OS expertise. So we can look at that and we'll look and see where the problem may be. Now, of course, if the issue is on the OS level, usually usually the OSs at that point, they've been around for a while and they're pretty stable. If you're looking at the older versions of things such as Solaris, such as True64, even VMS, there aren't too many, they've been around for a long time. And this goes back to my very first slide where these legacy applications are pretty stable, and so are the operating systems. But we will look at that, and we have enough expertise to be able to help do some initial troubleshooting. If there's a real bug or something like that, then it goes back to however you were dealing with the OS before you took it off the legacy system and you brought it into the emulator. One thing to note when you're talking about Solaris is, we talked about versions, is we currently, go up to 11.3. We do have in our roadmap to go to 11.4, but right now we support Solaris to 11.3, and we support VMS to the latest versions that run on, and True64 that run on the old legacy, like that ran on the alpha or run on the VAX. I hope that answered that. And like I said, we can go into more detail on a one-on-one basis.
Yeah, that's very helpful. I really appreciate both of you taking the time to answer everyone's questions. Just a quick reminder that this recording and the slides will be available. Let me go ahead and send the link now. That's available to OATUG members in the knowledge base. So I've just sent the link where that will be posted later today. And I just want to say again, a huge thank you to Marlin McNeil and Sandy Levitt for presenting this e-learning with OATUG and answering everyone's questions. I hope everyone enjoys the rest of their day, and thank you all for being with us.